7.1, we are going to talk about similarities in triangles, okay? When we talked about, before break, see if we can remember. When we talked about triangles being congruent, what are our options to prove that triangles are congruent?
Angle, side.
Angle, side.
Angle,
Angle, angle.
Side,
Side, side.
And side, angle, side.
Side, angle,
Sass.
side, and then there's a special one. Hypotenuse leg.
I said
Okay?
that.
That is if they are congruent. Do you see the difference here? What does this word say?
I know, we have a quiz Thursday.
Similarity. It does not mean that the triangle is congruent, it means that they are similar, okay? And if something is similar, what does that mean about side lengths? They have the same what? Starts with a P.
Yeah, proofs.
If two triangles are similar, they have the same what?
What's the second letter?
All the side lengths have to be the same what?
Proportions or
Yeah.
P? I was right.
Proportions.
Oh.
They have the same proportions.
Okay.
So to prove that triangles are similar, we have some theorems and postulates that we can use, okay? So the first one is the angle similarity postulate. AA only happens if you are proving something is similar, not if you're trying to prove it's congruent, if you're trying to prove it is similar. So you have angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if A is congruent to Z and C is congruent to X, then triangle ABC is similar to triangle ZYX. Okay? So you have AA similarity postulate. Does that make sense? Okay? And it's only when it only makes them similar. It does not make them congruent yet. We don't have enough information to prove they're congruent. Okay? But we do have enough information to prove they're similar by that. Okay, now, from that, we then head into some other ones. Okay, tell me, are the two triangles similar?
Yes.
Why do you say yes?
Two angles are congruent.
What two angles are congruent?
Oh wait.
N and Z.
No.
You said N and Z are congruent, what else?
Oh, yeah.
They're
Oh,
not
wait.
congruent,
They're congruent. These triangles are congruent.
Well, we don't know that for sure. You don't know that because,
Oh, yeah.
okay.
You're
So,
right.
why do you know that N and Z are both what degrees?
90
90.
degrees.
Okay, the Y is labeled as 60, but P is 30, so do those match up?
No.
No, but what is 90 plus 30?
120.
And what is that when I subtract 180?
60.
So what does that mean about angle M and angle Y?
They're similar.
They're congruent, so then I have similarity by what reason are they similar then? Angle. Okay, so sometimes not all the information is there, you have to start doing it again, remember?
I thought Alec was thinking through it, not thinking through it.
Yes.
Wait, so technically that was saying that angle M is congruent to angle Y?
I'm sorry, what?
Is it saying that like it's angle, what two angles are the same?
Angle N and angle Z are clearly the same.
Yeah.
Angle M and angle Y are the
Okay.
same. Angle P and angle X are the same. Okay, by the measurements we can tell that. Which of these statements is an acceptable way to write that the triangles above are similar? Check all that apply. So, is PQR similar to STU?
Yeah.
PQR, STU. Yes, okay. Is PQR similar to UTS?
No.
No, why not?
Because they're not ordered like.
They're not in the right order, right? Angle P and angle Q are not congruent, okay? Is PQR congruent? The boxes mean that there was a congruent sign there. Is PQR congruent to STU?
Yeah. No.
Would that be a proper way of writing it? PQR is
No,
congruent to
yes,
STU?
yes it would. Good
I don't
job.
know for
That
sure,
one's
though.
good. That one's good.
Okay, you would say sure, but the problem is what, Abby? What were you saying?
You don't know for sure that the other angle measures are the same.
No. You do know that the angles are the same, but what do you not know? In order for things to be congruent, 6 things have to be equal. The lengths of each side and the angle measurements. So can I say that those two triangles are congruent? No. What, Brandon?
I'm confused why there's a box.
Because it didn't transfer the
Okay.
congruent sign, right?
Then.
Is RQP similar to UTS?
Mhm.
Yes, good.
Yes.
Is RQP congruent to UTS? So your answer would just be no, we wanna check it.
Oh,
Is RQP congruent to STU?
no.
No, we don't have enough information. And clear, like, really by looking at it, I would say that this triangle is larger than that one too, right? Okay. Now, we solved some problems with this. Find two similar triangles. I wanna find two similar triangles. How can I do that? Do what? Proportions, okay? Proportions. Okay, so what do I need to set up then probably?
Oh,
What?
So you could do 36 over 12.
Okay, 36 over 12. Why did you pick those numbers?
Because they are, so CDE is one triangle, and then CAB is another triangle. CB is 36 and CE is
I
12.
know another
So it's just like a smaller
one. I
version.
know another one.
Okay, so here's the deal. If I'm you, because this is how I think, so just work with me real quick. If I'm you, because sometimes it's hard to see, I'll rewrite the two triangles out like this so that I have them in the order that they compare to. Does that make sense? Okay, and then I'll label stuff from there. So like this I know is 13, right? This I know is 12, this I know is 5. I know this, correct? So he did that just by looking at it, which is fine. Sometimes the pictures get more confusing, so drawing them out might help a little bit. But let's compare those. So you said take 36 over 12,
Correct.
and what does that reduce down to?
3.
3 over,
One.
when you have a proportion, you have to have a fraction.
Hmm.
You can, give me the fraction so that we can then, what am I gonna do
X
with
over
this?
5.
What am I gonna do with this fraction?
X
Yeah.
over 5.
I'm gonna set it equal to
X over 5.
x over 5, and then what do I do from there?
Proportions.
Cross multiply,
Oh yeah.
x equals
15, no, it's
15.
30.
Okay, so I can set up, and so my similar triangles, then how would I word that? What would that look like when I'm telling you that those two triangles are similar?
BA is similar to
I said, how would I tell you those two
DCE.
triangles?
B. Oh,
What'd you say, Alex?
DCE, ACB.
DCE is similar to what?
ACB.
ACB.
Correct.
Okay, you could write it like that, you can write it in any order, really, you all can have different answers as long as you're ordering
Oh,
those
yeah.
together. Okay?
I feel you.
Also, I know that those two triangles are similar without even doing proportions, why?
That's what I just like about it.
No,
Aw.
without even setting up proportions and finding side lengths that are proportional, why do I know those are congruent, or are similar?
They have the same angle C and then they have two right angles.
Good, they share angle C, which means that those two angles are congruent to each other, and then they both have right angles, so I could use a similarity as well. Okay? Now there is side, side, side similarity. Okay, so there's side, side, side for congruency, and there's side, side, side for similarity. Side, side, side for similarity is different though. It is not saying that every side corresponds to another side. It is saying that the proportions of every side are the same. So if I take AC over DE, that proportion has to be the same as AB over DE. And that proportion has to be the same as as BC over EF. Does that make sense? If each proportion breaks down to the same thing, okay? So if one of the proportions was 2/3 and another was 2/3 and one was 1/5, would those be side, side, side similarity? No, it would have to be 2/3, 2/3, 2/3. Okay, does that make sense?
Yep.
Okay, this isn't like super hard stuff to come back to. I like working with triangles better, they make life easier than those centroids and stuff, you know?
You.
Disgusting.
We ended on like the hardest chapter, like,
Yeah.
yeah.
Of the whole year or of that?
I, personally for me, of the whole year, but that's because I don't like to think that way and I can't visualize that very well.
Wish I would've done that today.
Okay. So, here we go, side, side, side similarity theorem. You have to tell me which triangles are similar. Is triangle NPM similar to BAC? NPM is the blue one. BAC is the red one. Now remember, order matters, yes? So if it's saying NPM, that means NP matches to what?
AB.
AB. So what's NP is 12, right? And AB is 18, so what's 12 over 18 reduced to?
6. Wait, no. Why is it so hard? 2 over 3.
2 over 3?
Yeah.
Okay, 2 over 3. So then I have to then take AC, right? And NM, is that correct? Yes, NM, no, and BC. NM over BC, yes?
Yeah.
Yeah.
And NM is 26. And BC is
39.
39. What's that reduced to? Are you positive?
Yes,
Okay.
13.
Thank you.
Yes.
And then I have to do PM, right? Over AC?
12 over 27.
12 over what?
27.
No, not 12, PM. 18.
Ooh.
What's that reduced to?
2/3.
Huh.
No.
Yeah, divide by 9.
Divide by 9. Mhm. So are those two triangles similar? Is triangle ABC similar to triangle XZY?
Gotta do it again.
How would you start that? What would I do?
Do the same thing.
Okay, so let's put AB and ZX together, right?
Correct.
So 18 and 24, what's that reduced to?
3 over 4.
3 over 4? Okay, and let's put AC and let's put ZY together, so just, what's 27 over 36 reduced to?
30 or 3 over 4. Because divide by 9.
Yes.
I think we're just
And
gonna go
let's put
3 or 4.
39 and 56 together?
3 or 4.
Does it come out to 3 over 4? Are you just saying that?
No,
What's it come out
I
to?
have no clue.
I'm
Doesn't
asking
look
for
right.
real.
I don't think 39 is.
39 is
It's only
fine.
divisible by
39 is only
72.
divisible by 3, right?
0.72.
Which would give you 13. Is 56 divisible by 3?
No.
Yes, it is.
No, because if you're going to try to get a 60, it'd be 57.
Right.
What?
So, are those similar triangles?
No.
No, because one of them is not proportional.
They're too big.
Okay? So it's just setting up a lot of things that I'm breaking down. Last one, show all
Just for
3 triangles are similar. How can I show that all 3 triangles are similar?
Because,
What did they give you to work with?
Angles.
So
Okay.
did you- Oh, and sides.
And they gave us sides. Okay.
only on.
On 2 of them, they gave us sides, and then on 2, they gave us angles, yes?
Yes, sir.
Okay, so let's start with the sides. Let's start with this and this over here, okay? Let's say 4 and 2 go together, so 2 over 4 is 1/2, right?
You just multiply by
And then
2.
3 over 6 would go
Yeah.
together because this makes sense, right? Because this is 47 and 47, so those go.
Yes.
It's
Okay,
right.
and that's how I'm figuring out what goes over what. Does that make sense, what I'm saying?
Yep.
Okay. And then I would have 3 over 6, which is 1/2, and 4 over 8, which is 1/2. Those two check out. Now, you know that these two are 104, yes?
Correct.
Okay, and what's 104 and 29 added together?
33. Or 133.
And what's 180 minus 133?
47.
47. So that's how I can prove all those, yeah?
I just looked.
He's just being sweet. Okay, so that's how I can prove all those. You're gonna have to show me work on that, understood? Okay? Last one, we can solve stuff of heights of different things. And this is where we start to get into this chapter. It's starting to lead into our little introduction of pre-calc. Okay?
Yeah, yeet.
Okay. So it says the height of a tower, okay, is 5 foot, do you see how that tower is 5 feet or whatever? Okay, and then,
Jack, don't die.
and then it's 8 feet
That's
tall.
not healthy.
Okay, this person right here is 5 feet tall, okay?
Short.
And she's 8 feet from this surveyor, okay? 8 feet from the surveyor. They wanna know how tall is the tower then? If the tower is 300 feet from the surveyor, what would you put, how would you solve that?
5 over 8.
30 over 8. Or 300 over 8.
Okay, 300 over 8
Oh, wait, yeah.
equals what?
So much
Equals what?
useful without fully.
5.
For real, though.
not 5.
I need to
It
know.
doesn't come out clean.
Five has to go with what? What number does 5 have to go with?
The
Oh,
other.
so it would be.
Five has to go with the X.
X of,
Yeah, so it would be x over 5. So then when I cross multiply yes,
Yes.
you get 1500
Yes.
divided by
equals 8x.
Yes.
Divide,
And what
and you
does x
get,
equal?
Ooh.
not a good number.
Yeah, I know. It's not a good.
Can you have decimals in your answer?
No.
Well, see, I can't do the decimal thing in my head.
Yeah. We're not calculators.
187.5.
That would be feet, right?
Then you
Yeah.
say
FT.
Okay. So,
187.5.
welcome back to geometry. You will have decimals in your answer. Okay? Those are the things you're working on tonight, similarity stuff. So it's all proportions.
I was